How far away is Voyager 1 from Earth? In 1977, NASA launched Voyager 1, one of the most ambitious space missions in history. More than 4 decades later, it remains humanity's farthest-reaching spacecraft, venturing into the vastness of interstellar space. Its distance from Earth is now measured not in millions but in billions of miles or kilometers, and continues to grow every second. As of October 2024, Voyager 1 is over 14.6 billion miles, 23.5 billion kilometers, away from Earth, continuing its historic journey beyond our solar system. But how do we measure such staggering distances, and what do they reveal about both the spacecraft's journey and our place in the cosmos? This article explores the various ways scientists measure the distance to Voyager 1, the challenges involved in communicating with a spacecraft so far from home, and the broader implications of Voyager 1's mission. Understanding how far Voyager 1 has traveled not only offers insight into its groundbreaking mission, but also deepens our understanding of the vast scale of space itself. The launch and early journey of Voyager 1. Voyager 1 was launched on September 5, 1977, from Cape Canaveral, Florida, on a mission to explore the outer planets of our solar system. It quickly became a trailblazer in space exploration, visiting Jupiter in 1979 and Saturn in 1980. These flybys provided stunning images and valuable scientific data, such as detailed observations of Jupiter's Great Red Spot and the discovery of volcanic activity on the moon Io. Voyager 1 also studied Saturn's rings and the moon Titan, which would later lead to the Cassini mission's exploration of this intriguing satellite. After completing its primary mission of exploring Jupiter and Saturn, Voyager 1 was directed on a path that would take it out of the solar system. By 1980, it was already millions of miles from Earth, heading toward the boundary of our solar system known as the heliosphere. It has now been traveling for over 47 years, constantly moving farther away from its home planet. Measuring Voyager 1's distance. Voyager 1's distance from Earth is constantly increasing as it travels at an average speed of approximately 38,000 miles per hour, 61,000 kilometers per hour. This means that every day, Voyager 1 moves about 900,000 miles, 1.5 million kilometers, farther from Earth. Measuring such a vast distance is a complex task that requires precision and advanced technology. Light travel time, a key measurement tool. One of the primary ways scientists measure Voyager 1's distance from Earth is by calculating the time it takes for signals to travel between the spacecraft and NASA's Deep Space Network, DSN, which communicates with the spacecraft. Voyager 1 communicates via radio waves, a form of light that travels at approximately 186,000 miles per second, 300,000 kilometers per second. Even at this incredible speed, signals take over 20 hours to travel from Voyager 1 to Earth. This delay, known as light travel time, is a key measurement used by NASA to determine the spacecraft's distance. As of October 2024, it takes approximately 21 hours and 20 minutes for a signal from Voyager 1 to reach Earth. Multiplying this time by the speed of light gives us a rough estimate of its distance from Earth. Over 14.6 billion miles, 23.5 billion kilometers. Astronomical units, a convenient scale. Another way to express Voyager 1's distance is in astronomical units, AU. 1 astronomical unit is the average distance from Earth to the Sun, approximately 93 million miles, 150 million kilometers. Using this scale helps make sense of the vast distances involved in space exploration. Voyager 1 is now about 157 Australian dollars from Earth, meaning it is 157 times farther from Earth than the Earth is from the Sun. This scale offers an accessible way to grasp the enormity of Voyager 1's distance from our planet. In comparison, Pluto, the farthest planet, or dwarf planet, from the Sun, is located about 39 Australian dollars from Earth at its farthest point. Voyager 1 is now over 4 times farther away than Pluto, well beyond the most distant planets in our solar system. Voyager 1's journey beyond the solar system. In 2012, Voyager 1 made history by becoming the first human-made object to cross into interstellar space. This boundary, known as the heliopause, is where the influence of the Sun's solar wind ends and the spacecraft encounters the interstellar medium, the sparse material that fills the space between stars. The heliopause is often considered the outermost boundary of the solar system. Crossing the heliopause was a monumental achievement, marking the spacecraft's official entry into interstellar space. At that time, Voyager 1 was about 121 Australian dollars from the Sun, or 11 billion miles, 17.7 billion kilometers. Since then, it has continued its journey outward, moving farther into the unknown regions of space that lie between the stars. Although Voyager 1 is now in interstellar space, it is still relatively close to the Sun when compared to the distances between stars. The nearest star to our solar system, Proxima Centauri, is about 4.24 light-years away, or approximately 268,000 Australian dollars. At its current speed, Voyager 1 will take over 40,000 years to come close to another star system. Nevertheless, its voyage has provided unprecedented insights into the nature of interstellar space and the boundaries of our solar system. The challenges of communicating with Voyager 1. Voyager 1's great distance from Earth presents significant challenges for communication. NASA relies on the Deep Space Network, DSN, a global system of antennas located in California, Spain, and Australia, to send commands to the spacecraft and receive data in return. However, given Voyager 1's distance, maintaining a reliable communication link is not easy. As the spacecraft moves farther away, its signal becomes weaker. The DSN uses large radio antennas, some of which are 70 meters, 230 feet, in diameter, to detect Voyager 1's faint signal. The spacecraft transmits data at a rate of about 160 bits per second, an incredibly slow speed compared to modern internet connections. Despite these limitations, Voyager 1 continues to send valuable scientific data back to Earth. Another challenge is the delay in communication due to the vast distance between Voyager 1 and Earth. As mentioned earlier, it currently takes more than 21 hours for a signal to travel one way. This means that even a simple command from Earth takes nearly 2 days to reach Voyager 1 and receive a response. In addition to communication delays, Voyager 1's power supply is dwindling. The spacecraft is powered by 3 radioisotope thermoelectric generators, RTGs, which convert the heat from the radioactive decay of plutonium-238 into electricity. These generators were designed to last about 40 years, but as of 2024, they are still functioning, albeit at reduced power. NASA has gradually turned off non-essential instruments to conserve energy, and it is estimated that by 2025, Voyager may first no longer have enough power to transmit data. The scientific legacy of Voyager 1. Despite the growing distance and communication challenges, Voyager 1 continues to provide groundbreaking scientific data. One of its most significant contributions since crossing into interstellar space has been its measurements of the interstellar medium. The spacecraft's Plasma Wave Subsystem, PWS, has detected the density of plasma in interstellar space, providing the first direct measurements of this region. The data shows that the interstellar medium is much denser than the solar wind-dominated environment Voyager 1 traveled through before crossing the heliopause. Voyager 1 has also provided important information about cosmic rays, high-energy particles that originate from outside the solar system. The spacecraft has detected an increase in the intensity of cosmic rays since entering interstellar space, giving scientists new insights into the forces at work in our galaxy. These measurements are helping scientists refine their understanding of the boundary between our solar system and the rest of the galaxy. The data Voyager 1 provides from interstellar space is invaluable, as no other spacecraft has ventured this far from Earth. The future of Voyager 1's journey. Voyager 1 will continue its journey through interstellar space indefinitely, even after its instruments stop functioning. At its current speed of about 38,000 miles per hour, 61,000 kilometers per hour, it will take more than 40,000 years to approach another star system. In about 300 years, Voyager 1 will travel far enough that the Sun will no longer be the brightest star in its sky. As Voyager 1 moves deeper into interstellar space, it will remain a silent testament to humanity's desire to explore the cosmos. Even when its power supply is depleted, Voyager 1 will continue to drift through the galaxy, carrying with it the golden record, a message intended for any extraterrestrial life that may encounter the spacecraft. The golden record contains sounds, images, and music from Earth, representing a time capsule of human culture and a greeting to any potential alien civilizations. Understanding the vastness of space. Voyager 1's incredible distance from Earth underscores the vast scale of space. To put it into perspective, The distance Voyager 1 has traveled since its launch is over 14.6 billion miles, 23.5 billion kilometers. Even light, which travels at 186,000 miles per second, takes more than 21 hours to cover this distance. In contrast, light from the Sun takes just over 8 minutes to reach Earth. The sheer size of the space Voyager 1 is traversing challenges our comprehension. The distances involved are so vast that they are difficult to fully grasp. For example, while Voyager 1 is far beyond the planets of our solar system, it is still relatively close in galactic terms. It will take tens of thousands of years for the spacecraft to travel even a small fraction of the distance to the nearest stars. Voyager 1's journey is a powerful reminder of both the vastness of space and the remarkable achievements of human space exploration. It has traveled farther than any other spacecraft and continues to push the boundaries of our knowledge about the universe. Conclusion: Voyager 1's enduring mission. As of 2024, Voyager 1 is more than 14.6 billion miles, 23.5 billion kilometers, from Earth, continuing its journey into interstellar space. Its distance from Earth is constantly increasing, and with every passing second, it moves deeper into the unknown. Despite the immense challenges posed by its distance, Voyager 1 continues to send valuable scientific data, offering insights into the nature of interstellar space and the boundary regions of our solar system. The spacecraft's incredible journey is a testament to human ingenuity, curiosity, and our desire to explore the universe. Voyager 1's mission will one day come to an end when its power supply is exhausted, but its legacy will live on for generations. Even when Voyager 1 is no longer operational, it will continue its journey through the galaxy, carrying with it a message from humanity to the stars. Its distance from Earth serves as a reminder of both the vastness of space and the extraordinary achievements of space exploration. As Voyager 1 continues to travel farther from Earth, it becomes a symbol of humanity's place in the cosmos, pushing the limits of exploration and expanding our understanding of the universe we inhabit.